All right, so next part of our lesson in measuring 2D and 3D figures, lesson 12.5. And we are going to be learning about surface area of prisms and pyramids today. So our learning target, I can find the surface area of solids by relating the nets of these solids to the formulas for surface area. And the vocabulary that we are going to learn today: face, lateral face, regular pyramid, slant height, and surface area. So I want to like quickly refresh your memory as to what a net is. And if I look at the vocabulary over here, we're talking about what surface area is of prisms. And so these, in the front and the back, the top and bottom and the two sides, if I take any prism, so top and bottom, front and back, side and side, these are nothing but the faces. Okay, we don't say sides as we did in polygons. In polyhedra, we always say faces. Okay, because these are the faces of the prism. Okay, so when I look at this, so the sum of the areas of all the surfaces or faces of a three-dimensional figure is the surface area. So when I add up the areas of all of these together, of all the surfaces, that is what surface area of a three-dimensional shape is. Okay, so when you find the surface area of a three-dimensional figure, the units are square units. So instead of like when we do volume, it's cubic units. But when we are finding surface area that is outside, just think of when we are wrapping paper, uh, that's the surface area. You know, whenever you are wrapping a gift or something like that, so that is surface area, what's on the outside. Okay, that's covering. So that's why that's going to be square units. Okay. Now, to find the surface area of a rectangular prism or a triangular prism, you are going to find the area of each face, and then you're going to calculate the sum of all the faces. So I just want to show you, I've drawn something over here. If I look at any box or any, because what is a box? Box is a prism, right? So if I look at a prism, let's say this is a rectangular prism. Okay, I am going to have a top and I'm going to have a bottom. Okay, now obviously on a 3D shape that you're drawing, you can see one part, you can see the back, right? So if I have a top, I also have a bottom, right? If I have a front, I also have the back. All right, and then if I have a side, I have another side. So it's always like, because it's a hexahedron, okay, that means there are going to be 6 faces. All right. So if I were to actually open up a box, think about Pizza Hut and all these places, most of those hexahedrons, that means the box in which your pizza is sent home, they are normally stored flat, and that is then folded into a box. And the purpose of that is, again, to maximize the storage space. But if you've gone in ever and you've looked at those, so look, this is a box, which if opened up, it can look like a T. It can look like something that I have drawn over here. So that this is called a net. A net is nothing but a 2D, shape of a 3D shape when it is opened up. Okay, so this is the net of a rectangular prism. And then, when I do this, inside would be volume, but outside would be the surface area. Okay, let me show you of a cube. Again, this is a cube. And when I open this, and I have like done an entire lesson on nets, you'll find it in the 6th grade folder, not in the 7th grade one, but I'm just going to show you this really quick. So here is a cube or a square prism. So as you can see, all the faces are going to have exactly the same measure. In fact, this is the easiest surface area to calculate, because since all the measures are the same, you calculate 1 times 6. So area of 1 times 6, because it's a hexahedron. So it becomes pretty simple, all right, to calculate the surface area. Then if I have a triangular prism, I know that based on the triangles that I have, I'm going to have 5 faces over here overall, because we had talked about the sides of a triangle plus 2 for prism and plus 1 for a pyramid, right? So look, so this is what the net of a triangular prism looks like. So we would have to calculate 5 faces over here. Okay. Now again, depends on whether it's an equilateral triangle, isosceles triangle, or a scalene triangle. If it's equilateral, like in this case, obviously these two are going to have the same measure, and because it's equilateral, all these square or rectangular faces are going to have exactly the same measure. Okay, in this case, obviously square because it's equilateral. If it was isosceles, 2 of them would be the same and 1 would be different. If it was scalene, none of these rectangular faces would be the same. Okay, so depends on the shape of the triangle that you have in that pentahedron. All right, and then this is a tetrahedron. This is a triangular pyramid. Okay, so if I take this out from here, look, this is what the net is going to look like. And so I would just have to obviously find the 4 faces. Okay, and since they're all triangular, obviously it would be 4 triangles over here that we are calculating the area of. And this is again a pentahedron. It's a square pyramid. And if I take this out and I open it, here's the net. Okay, so you would have this area and then these 4 triangular areas. So square and the 4 triangles. Okay, so in this way, all shapes, when they are opened up flat, you know, you get a net. This is a cylinder. If I open this, here, a lot of things. Actually, it looks like a division sign, if you think of it. 1 rectangle, and then you have the 2 circles, right? And I'm going to show you 1 or 2 more. And then if I have a cone, and if I open this up to see what the net of a cone would look like, let's see. So here's a cone. And when I open it, it looks like this. Okay. And I'll show you one last one. This is a prism, because top and bottom are exactly the same. And knowing on how many sides do I have, 1, 2, 3, 4, 5, 6, it's a hexagonal prism. So if I open this up, look, here's the net. Okay, so since it's hexagonal, how many sides do you think the rectangles will be? 1, 2, 3, 4, 5, 6. So 6 of those rectangles. And then I have, of course, the base and the top are going to be a hexagon. All right. So this is how nets are nothing but a 2-dimensional representation of a 3D shape when it is pulled open. Okay. So now, for us to calculate the surface area of a prism, you've got to remember that if you have a top, you also have a bottom. If you have a side, you have another side. If you have a front, you have a back. So either you can pull it apart as a net and calculate. Okay, because see what I've done over here. Yeah, let me bring you closer so you can see. All right, so I've taken this the rectangular prism, and you can see that, look at my dimensions. I have 8 times, if this is 6, this is 6. So front would be what? 8 and 6. So you can either do it this way. You can also split it up if you find that easier. So I can do this. I can do 8 and 6. All right, that's one rectangle. And what is 8 times 6? I'm going to get 48, because area is length times width. So since area is length times width, I'm going to calculate each area. Okay, so if I'm saying 8 times 6, so look, that's what I've done over here. I got 48. And if I have 8 times 6 here, I'm going to have another one, which is 8 times 6. Okay, so then let's look at the next option that we have here. We have the side, you have 7 times 6. Okay, so 7 times 6. And obviously, if I have one side, I'm going to have another side. Okay, so 7 times 6, as you can see, I've got 42 here. Okay, so 42 here. That's literally, I'm just breaking it apart even more. Okay, and then I have the top. So I can look over there. If this is 7, we know this is 7, right? And if this is 8, we know this is 8. So we have 8 and we have 7. And what is 8 times 7? I have 56. So if I can just break it apart like that, it becomes really visual for me to find the surface area of the shape. And then since I have 2 of these and 2 of these and 2 of these, whatever I get here, I can double it. But don't forget to double. That's where children normally go wrong, is like they just write it once, but then how's your box going to close? Because you only got like one of the faces from each side then, okay? So if I was to look at this, and I would be like, okay, is there a certain formula I can come up with, to know whether how to find the surface area? So yes, if I look at this, what is the surface area of a shape? Okay, you're going to have in this case, like see, 2 length times height plus 2. So each of them is 2. Okay, length times width plus 2. We have height times width. So basically, because this times this time, so y'all, all you need to do is you can just change up the combinations. Okay, you can do 8 times 7, you can do 7 times 6, you can do 7 times 6, and you can do your 8 times 6. So you've taken the 3 numbers, which is 6, 7, and 8, and you've done 3 different combinations, and that's basically what this is. Because I have combined 6 with 7, I've combined 6 with 8, and I've combined 7 with 8. So those are my 3 combinations. So it becomes pretty simple when you're finding the surface area, if you think of it that way. Okay, so now if I was finding the surface area of this shape, all I would do is I would 56 times 2. All right, so I could do 2 times 56, or I could do 56 plus 56, right? It doesn't matter. So I could do 2 times 56 plus 2 times 42 plus 2 times 48. So I've taken all of these and I have just doubled it. And so when I multiply and add, I am going to end up with 292 meter squared. Please remember that surface area is area, so it is square units and not cubic units, okay? So this is how we calculate the surface area of a shape. Feel free to break it apart and then do it, but don't forget to do the 2 times. Don't just do 56 plus 42 plus 48, because then you would get half this, which is not correct. It's not, surface area has to be all around the shape. Okay, so think of it like when you're wrapping a gift, you're not just wrapping part of the gift, you are wrapping the entire gift. Okay, so you will have a top, you'll have a bottom, you'll have a side, you'll have another side, you'll have the front, you'll have the back. So all of those have to be added up when we are calculating the surface area of a shape. Okay, now Let's try one over here. Okay. And so here is my question. And we are looking at this and we are going to now look at, okay, to calculate the surface area of the rectangular prism, I'm going to do my three combinations. All right. So, okay. So you've got to have the area of the two sides. You've got to have area of the top and bottom, and you've got to have the area of the front and back. Okay. So let's look at the area of sides. Okay, area of sides is going to be what? This is the side, right? So area of the side would be, what am I having? 9 and 2500 times 13 and 6/10. So this would be the area of the side. Okay, and so if I am doing this, this is one side. So obviously I have to do two sides because there are two sides, this side and the other side, right? So I have to do times 2, and I'm going to get 251 and 6/10 inches squared. So this is of the side. Okay, now let's look at area of top and the bottom. Okay, top and the bottom. So if this is 7 and 5/10, what do you think this is? This is also going to be 7 and 5/10, right? And then if this is 9 and 2500, this is also going to be 9 and 2500. So if I'm looking at the top and bottom, so this is the top and bottom, okay, this one was the sides, the two sides, right? So top and bottom, okay, area is, what did we say, length times width. Okay, so in a rectangle, it's length times width. So this is going to be, top and bottom would be 2 because I can just see the top over here. 2 times 7 and 5/10 times 9 and 2500. Okay, and so when I calculate that, I get 138 and 7500 inches squared. So this is going to be my top and bottom. Then I look at the front and back. Okay, so in my front, I have this, which is 7 and 5/10, right? And then my other measure for this, if this is 13 and 6/10, this is also going to be 13 and 6/10. Right? So now we have the front and we have the back. So that is 2 of them. So it'll be 2 times 13 and 6/10 times 7 and 5/10. And when we multiply that, we are going to get 204 square inches. So this is my front and back. Now you can see all the three measurements that I have here, and we are going to find, so literally that's what I'm doing, 2 times this, 2 times this, 2 times this, that, 2 times length times height plus 2 times length times width plus 2 times height times width. And so now for the actual complete surface area, whatever I found here, I am just going to add. So surface area is equal to 204 plus 251 and 6/10 plus 138 and 7500. So I've got to add all the different faces now. And when I add all of this, I end up, my surface area is going to be 594 and 3500. Okay, so 594 and 3500 inches squared. So this is my surface area of this shape. Okay, and that's how surface area is calculate it. Now, let's do one of a triangular prism. All right, so we saw how to do one of a rectangular prism. Let's do one of a triangular prism. Okay, so let's do this one. And let me show you a net of a triangular prism. Okay. It depends on the kind of a triangular prism, the triangle that I have, but I had shown you this. And so we know there are going to be 5 faces. Okay, the 2 triangles will be congruent. And then these depend on the kind of triangle, whether it is an equilateral triangle. If it's equilateral, all of these will be the same. If it's isosceles, 2 of them will be the same. If it's scalene, all of these will be different. So it depends on the kind of triangle that you have in the triangular prism. Okay, so there are definitely going to be 5 different faces over here. Okay, so we are going to so we know that in any triangular prism the bases are congruent, but the faces are not always congruent. So in this triangular prism there are 2 congruent triangular bases. Okay, and there are 3 rectangular faces, 2 of which will be congruent. Okay, so let's look at the area of the bases. Let's look at the area of the bases. Okay, so the base is a triangle, and so what is the area? So we have a triangle. Okay, and here we have 4 inches. We have 4 inches as your base. And then let's look at what the height is. And the height is given to you as 3 inches. It's given as 3 inches. Okay, so what is the area of a triangle? Okay, area is base times height divided by 2, or you can say 1/2 base times height. But over here, since we have the the 2 faces of the triangle are going to be congruent, so it has to be 2, because look, we have one here and we have one here. So that is why times 2. And so this is going to be times 2. Okay, and so we are going to do area is equal to 2 times, okay, what do we have as the base? We have 4 times 3, which is the height, divided by 2. Okay, and so all I can do, I can simplify. I can do 1 and I can do 2, right? So what is 2 times 3 is 6, and 2 times 6 gives me how much? I get 12 square inches. 12 square inches would be the area of the bases. Okay, now let's look at the faces now. So since this is an isosceles triangle, as I can see, 2 of the faces are going to have the same measure, and then the third face is going to be different. Okay, so let's look at the first face of the rectangle. Okay, so I have look, if I'm looking at this part, this rectangle here, okay, this one here, and so I have 3 6/10, right? So I have 3 6/10 times 14. So because area is what? Area is length times width. So this is for one of the faces. Okay, so I'm going to say face 1 is going to be, area is equal to 3 6/10 times 14. And so when I multiply that, I get 50 4/10 square inches. This would be the first face. Okay, now the back face, this one over here, you can see the back part of this you can't, but that has exactly the same measure as this. So therefore phase 2 will also be calculated in the same way. And phase 2 is also equal, area is the same measure. Okay, now let's look at the third phase, phase 3. Okay, so in this, my area is going to be this one. See at the bottom, what is this? This is 4 times 14. Okay, so area of the third one is going to be 4 times 14. And I get 56 inches squared. Okay, so now we are going to look at all of these areas, and surface area is what? You are going to add up all the faces or some of the areas of the faces. So surface area of the triangular prism is equal to 12 plus 50 and 4/10 plus 50 and 4/10 plus 56 square inches. And so when I add all of this up, I'm going to get 168 and 8/10 square inches. So this is going to be the surface area of this triangular prism. Okay, now let's talk about the surface area of pyramids. Okay, surface area of pyramids. So I will come back to this, but let me just show you certain words that would help you with the vocabulary. Okay, so if I take a regular pyramid is a pyramid whose base is a regular polygon. Okay, so all right, so let's see, let me take this one for example. So this is a regular pyramid. Okay, now so base is a polygon. As I can see that this is a square. All right, and then we have all these faces that are going towards the apex at the top, the vertex on the top. Okay, so a pyramid whose base is a regular polygon, that's what this is. And then the lateral faces are these, which are not the base. Okay, so these are my lateral faces. Okay, and then this is definitely the base, and then the height of this is called the slant height. So let me just draw it out so you can see when I am actually going to open up this and look at the net. This is what it looks like. So I'm just going to draw this out so you can see. Okay, so we have a square, and then we have 1, 2, 3, and 4 triangles. Okay, now once again, look at these. These are your triangles that are meeting at the vertex at the top. Okay, the vertex at the top. So this is where they're all joining. That's called the vertex on the top. Okay, so therefore this is the base, and then each of these has a certain height, right? Each of these has a certain height, and the height, and so each of these over here, these are called lateral faces. Lateral faces. Okay, this is a lateral face. All of these are lateral faces. Okay, all of these. This is lateral. And of course, this is your lateral face. Okay. So, because what did I say? What was the lateral face? The lateral faces, the faces that are not the base of a regular pyramid, are congruent isosceles triangles that meet at the vertex. Okay? So these are all lateral faces, and this is the base, and on the top they are meeting at the vertex, and the height of each lateral face, is called the slant height. So this height of all of them, this height, this height, this height, this is called the slant height. Okay, so this is called the slant height. So I just wanted you to have a comprehension of this before we start working on the surface area of a pyramid. Okay, so now let's go ahead and we are going to solve a problem. Please remember, you can use the areas of the lateral faces and the base to find the surface area of a pyramid. So what I would do, I would find the area of this, and you can find the area of one triangle, since they're all congruent, times 4, and then I would add them all up, and that would give me the surface area of the pyramid. Okay, so now let's go back over here to look at our question. And here is the question. It is saying, find the surface area of the pyramid. Okay, find the surface area of the pyramid. So let's look at this pyramid, and we can just look at the base of the pyramid first. Okay, and we can see that the base of the pyramid is a square, and what is this measure? It's 4.5. Okay, so 4.5 inch sides. So what is the area of a square? Area of a square is side squared. Okay, so if I do 4.5 times 4.5, okay, so this is 2 times 4 is 8 plus 1, which is 9/2 times 9/2. Okay, I get 9 times 9, 81. 2 times 2 is 4, which gives me 20 times 4 and 1/4. So 20 and, okay, there we go. 20 and 1/4 inches squared. I just want to write this here, but it's not kind of fitting. There we go. All right, so let me just remove this part. Okay, so 20 and 1/4 inches squared is the area of the base. Okay, and then now let's look at the different the lateral faces. The area of the lateral faces now. Remember, lateral face is everything which is not the base. Okay, so area of the lateral faces. We know that you have the base length as 4.5, and the height is 11 and 1/4, right? So what we're going to do, and there are 4 triangles when we open it out. There are 4 isosceles triangles, okay, which have exactly the same measure. That's the only way it's going to close, right? So area of a triangle is what? Base times height divided by 2, right? So we are going to do area of a triangle. You can say base times height divided by 2, or you can say 1/2 base times height. Both means the same thing. Okay, now since there are 4 of them, we are going to do times 4. Okay, whichever works for you, you can use that. And so area is going to be 4 times 1/2, because 1/2, you can just divide by 2, or you can say 1/2 times, what is my base is 4 1/2. What is my height, it's 11 and 1/4. Right? And then we are going to change these mixed numbers to improper fractions because that's the only way we multiply fractions, right? And so we are going to do 4. We can make this over 1 times 1/2 times, what is 2 times 4? 8 plus 1, that gives me 9/2, times 11 times 4 is 44 plus 1, that gives me 45/4. Okay, now definitely you can simplify before you multiply. Okay, and or I can just multiply 4 times 1 times 9 times 45. Okay, and then but that becomes like pretty tedious, and but anyways, I am just going to simplify because 4 and 4 cancel each other out. Okay, and so then I have 2 times 2 at the bottom, so this is equal to 2 times 2 is 4, and then I have 45 times 9. What is 9 times 5 is 45, 4, and 9 times 4 is 36 plus 4, and I get 405. Okay, so 405/4. And then when I convert this back to a mixed number, I am going to get 101 and 1/4 square inches. Okay, 101 and 1/4 square inches. So what would the total area be? It would be this plus this. Okay, so total surface area of the prism is going to be the total surface area is going to be the area of the lateral faces, which is 101 and 1/4, plus the area of the base, which is 20 and 1/4. Okay, and here we go, 20 and 1/4. And so when I add this up, I am going to get 121 and 1/2. Okay, 121 and 1/2 square inches. Okay, there we go. We get 121 and 1/2 square inches would be the total surface area of this shape. Okay, since we are adding, we're just doing 101 plus 20, and then 1/4 plus 1/4 becomes 1/2. Okay, so that is how we calculate the surface area of a pyramid, of a square pyramid. Okay, if the base was not a square, would the 4 triangular faces be congruent? Absolutely not, because in the pyramid, the base must be a regular polygon. It should be an equilateral triangle, it should be a square, etc., for the triangular faces to be congruent. Okay, so that concludes our lesson on surface area of prisms and pyramids. Just remember the different faces, and basically you're just finding the surface area of each face, and then you are adding them all up. And of course, since it's area, the answer is going to be in square units. Please remember what slant height means and what the lateral faces mean. Lateral faces is everything but the base, and the height of those lateral faces in that slant, that is called your slant height. Okay, this part, these are all your slant heights. Okay, when we open it, of course, it's going to be flat as a net, but when I show you this, this is my base and these are my lateral faces, and then this is the slant height. So just remember this vocabulary, and in surface area, all you're doing is finding the area of each face, and then you are adding it all up together. All right, have a great day, everyone.